Assalamualaikum and a very good day everyone. In this video, we will talk about our teaching aids. In this teaching aids, we will talk about the topic of monosaccharide, which is under the topic of carbohydrate. In this teaching aids, we will talk about the introduction, physical properties, chemical properties, application, and test, and the importance of monosaccharide. In this teaching aid, we will have the visual learning, hands-on learning, and the Q&A session in quizzes. This teaching aid consists of two components. The first one is the book of monosaccharide, and the second one is the material kit. Both of these components will be explained in the next part.
Alright guys, so in this part, I'm going to explain to you guys each pages that exist in this first component of our teaching aid, which is the book of monosaccharide. This book of monosaccharide consists of 10 different pages from the cover page to the back page. With each of the pages consists of introduction, properties, reaction, and important monosaccharides. In this video also, I'm going to explain to all of you on how to use each pages for the teachers who are going to use this teaching aid in the class. Alright, so the first page after the front page is the first part of the topic, which is the introduction and also the physical properties. For this page, we give you crossword puzzle where the students and teacher can detach the alphabet and let the student arrange the alphabet to make up a phrase or a word based on the questions given in the crossword. For example, the first one is extremely XXXX in water. With hint, it becomes syrup when mixed. So the correct answer is soluble. So when the students answer the question, they will attach the alphabet to make up the word of soluble.
For classification of monosaccharide, I will show you how to construct your own monosaccharide based on this page that will help you to construct your own monosaccharide based on this flow, which is type of carbonyl, number of carbon, and the stereoisomer that exists in the monosaccharide. First thing first, as mentioned before, this is the material kits that will be used for these pages to build your own monosaccharide. As you can see here, this is monos tower, that stands for monosaccharide tower. This will be used to construct your own monosaccharide. Based on the hint that was given at the bottom of the page, you can have your own structure from carbonyl, which is ketone and aldehyde, to numbers of carbon chain. For this example, you have to choose first your type of carbonyl. I will choose aldehyde. And then you can choose your number of carbon up to 7 carbon. For this example, I will fill up all this space. Please be minded that for monosaccharide, at the end of the structure will have the hydroxyl group. Then after you finish build your own structure, you can see this is aldehyde, so I will choose aldo. And then number of carbon 1, 2, 3, 4, 5, 6, which is hexose. And then for this empty space, this is specifically for stereoisomer. For stereoisomer, you have to determine the L or D direction based on the second last carbon chain further from carbonyl group. As you can see here, 1, 2, 3, 4, 5. the fifth. As you can see, this fifth carbon chain, the OH group is on the left side. So, the left side is the L direction. And then that is the end of your construction of your own monosaccharide, L-aldohexose.
Continuously from the previous part of classification of the naming of monosaccharide, in this part you are going to be tested on how you name the monosaccharide depending on the tastes that are given here. For example, you are given a lot of cookies on this page. Your task is to name the structure and put it on the correct jar of its name. First one, you need to identify the type of carbonyl, then the number of carbon, its determination of L and D, and the last one, alpha or beta. When you determine the name, you can match it according to the correct group of its naming.
For chemical properties, this page will help you to understand that monosaccharide does not exist in an open chain, but they usually exist in form of ring. For glucose, for the example, they usually will produce a Pyrenees ring, consists of 5 carbon. As you can see, this diagram will be zoomed out to this whole diagram. This oxygen will be bonded to this carbon. And then this hydrogen will be attached to this oxygen. So, throughout a complex mechanism, this oxygen to carbon bond should be a single bond. So this page should help you to understand the mechanism of how this open chain became a ring structure. And then after you produce your monosaccharide ring, there will be either the OH group is at the bottom or at the top. If the OH group is at the bottom, it will be named as alpha glucose. If the OH group is at the top, it will be named as beta glucose. Same goes for whatever monosaccharide ring you are building. For example, for fructose. If the OH group is at the top, it will be named as beta fructose. And again, if the OH group is at the bottom, it will be named as alpha fructose. So this page will help you to understand what is the naming of the anomers of the monosaccharide depends of the OH group.
So for this chemical properties part, we are giving you a simple visual learning activity in which this part we provide you the equation and the color for you to understand the process of reaction in the chemical properties of monosaccharide. In this part, we have 3. The first one is oxidation, the second one is ester phosphate formation, and the third one is glycoside formation. For the oxidation process, we give the equation of oxidation of monosaccharide under the addition of Benedict's reagent, and the precipitate of copper 1 oxide will be produced to make up the brick red precipitate. We also shows you the result for Benedict's test result if the solution consists of monosaccharide or if it doesn't have any reducing sugar in the solution. For the phosphate ester formation, we give you a big structure of an example and also the correct equation from glucose to the glucose 6-phosphate or G6P. You can also detach the phosphate group and attach it back to the bond that will connect the phosphate and the glucose.
So the next one is the glycoside formation, where hemiketal or hemiacetal, which is the reducing sugar, will react with alcohol and produce 2 anomers. The anomers is methyl diglycopyranoside. It can be alpha or beta depending on the glycosidic linkage location. When the glycoside product react with Benedict reagent, it will produce no reaction. Next, moving on to important monosaccharide. So, in this book, we have concluded to you some examples of the important. The first one is honey, second one is RNA, DNA, and also milk. So, for your guys' information, you can flip up the example and you can observe the structure, and also you can read the important monosaccharide in this book. Now, I will show you guys on how to use the QR code on the book to answer the multiple choice question. First thing first, you need to open up your scanner application and then scan the QR given, and the QR will lead you guys to an application that called Bluecard. And then when it's already show you the name, you need to enter your name, click the new game, and then you can choose your difficulty. If you are pro like me, you don't need to use the tutorial, and you may start your game by answering the question first, and you can play the game later. It's just with 2 to 3 steps, and you can play the quizzes and enjoy the game. In conclusion, we really hope that this teaching aid can help the student with the subtopic monosaccharide, and it will help in the study in the long run. That's all from us. Thank you.